troubleshoot a missing phase, specifically the C leg, in a 480/277V 3-phase lighting system with 40 lights controlled by a photocell and contactors. Several steps should be taken. Firstly, confirm the health of the circuit breakers associated with the C leg. Even if they don't appear tripped, manually reset them. Sometimes a breaker can trip without a clear visual indication. Secondly, inspect the wiring connections within the electrical panel itself, paying close attention to the C-leg terminals. Ensure all connections are tight and secure. Loose connections can cause a loss of power. Thirdly, use a multimeter to test the voltage between the C-leg and neutral at the load center. If there is no voltage present, the issue may lie upstream, meaning closer to the power source. Fourthly, trace the feeders from the load center back towards the service entrance. Look for any signs of damage to the wires themselves, disconnected wires, loose connections, or tripped fuses, if applicable. Fifthly, verify that the main disconnect for the electrical service is in the on position. A simple check, but easily overlooked. Sixthly, contact the utility company to confirm that there is power being supplied to the building. There could be an issue on their end affecting the supply to the C phase. Seventhly, inspect the photocell and contactors. Ensure the photocell is functioning correctly by checking for both voltage and continuity. Inspect the contactors for any signs of damage or malfunction, as these are responsible for switching the lights on and off. Eighthly, consider the possibility of a load imbalance. If the other phases, A and B, have lights operating, an uneven distribution of the electrical load across the phases could be contributing to the problem. Check the wattage and load distribution for each phase to identify any significant discrepancies. When working with electrical equipment, always exercise caution. If you are not comfortable troubleshooting electrical systems, it is recommended to contact a qualified electrician. Keep a detailed record of all troubleshooting steps taken. This can be valuable for future reference and for assisting an electrician if needed. Replace any damaged or faulty components as you identify them. These steps cover the essential areas to investigate where phase is lost in a 3-phase lighting system. Remember, safety is paramount when working with electricity. Always de-energize circuits before working on them whenever possible, and use appropriate personal protective equipment. Remember to use a calibrated and reliable multimeter for accurate voltage and continuity testing. When checking voltage, verify that the multimeter is set to the correct voltage range, in this case appropriate for measuring 480 volts. When checking continuity, ensure the circuit is de-energized. Start at the load center and methodically work your way back toward the power source, checking each connection and component along the way. If a specific contactor is suspected, bypass it temporarily, if safe to do so, to see if the power returns to the C leg. Be extremely careful when bypassing any safety device. Always consult with a qualified electrician before undertaking such a procedure. When inspecting the photocell, check its wiring connections and ensure that it is receiving the correct voltage. Also, check the photocell sensitivity setting to ensure it is not set too high, which could prevent it from activating the contactors. If the load is imbalanced, redistribute the lighting load across the 3 phases to even out the current draw on each phase. This can help prevent future problems. Refer to the National Electrical Code, or NEC, for guidance on proper wiring practices, overcurrent protection, and load balancing. For example, NEC Article 220 covers branch circuit, feeder, and service calculations, which are essential for ensuring that the electrical system is properly sized and balanced. Also, NEC Article 310 provides information on conductor ampacity, which is crucial for selecting the correct wire size for the lighting circuits. If you find any damaged or deteriorated wiring, replace it with wiring of the same size and type. Be sure to properly terminate all wiring connections using appropriate connectors and tools. When working in hand halls, be aware of potential hazards such as underground utilities and wildlife. Use appropriate safety precautions such as wearing gloves and eye protection. If you suspect that there is a problem with the grounding system, consult with a qualified electrician to perform a ground resistance test. A properly grounded system is essential for safety and for preventing electrical problems. Consider using a power quality analyzer to monitor the voltage, current, and harmonics on each phase. This can help identify any underlying power quality issues that may be contributing to the problem. When troubleshooting, it is helpful to have a wiring diagram of the lighting system. This can help you trace the circuits and identify the location of components. If you are unsure about any aspect of the troubleshooting process, it is always best to consult with a qualified electrician. Electrical work can be dangerous, and it is important to take all necessary safety precautions. Remember to energize the circuit before working on it. Use a properly rated voltage tester to verify that the circuit is de-energized. Wear appropriate personal protective equipment, such as gloves and eye protection. Work in a well-lit area. Do not work alone. Inform someone of your location and the work you are performing. Keep a fire extinguisher nearby. Be aware of potential hazards such as water and metal objects. Never assume that a circuit is de-energized. Always verify with a voltage tester. If you are not comfortable working with electricity, contact a qualified electrician. They have the knowledge, skills, and experience to safely troubleshoot and repair electrical problems. In addition to the steps already outlined, consider the possibility of a faulty neutral connection. A poor or broken neutral connection can cause voltage imbalances and other electrical problems. Check the neutral connections at the load center, the service entrance, and any intermediate junction boxes. Ensure that all connections are tight and secure. Also, check the neutral conductor for any signs of damage or corrosion. Another potential cause of a missing phase is damage to a corroded busbar in the electrical panel. Inspect the busbars for any signs of discoloration, pitting, or corrosion. If you find any damage, the busbar may need to be replaced. If the lighting system includes any surge protective devices, or SPDs, check them to see if they have been damaged or have tripped. A damaged or tripped SPD can block the flow of current to a particular phase. Be sure to replace any damaged SPD with new ones of the same type and rating. If the lighting system is controlled by a building automation system or BAS, check the BAS to see if there are any settings or overrides that could be causing the problem. For example, the BAS may have been programmed to turn off the lights on the C phase during certain times of the day. Also, check the BAS for any error messages or alarms that could indicate a problem with the lighting system. If the lighting system is connected to a generator, check the generator to see if it is operating properly. A faulty generator can cause voltage fluctuations and other electrical problems. Also, check the generator's transfer switch to make sure that it is switching properly between utility power and generator power. If the lighting system includes any dimming systems, check the dimming system components, such as the dimmers and ballasts, to see if they are functioning properly. A faulty dimmer or ballast can cause a loss of light output or a complete failure of the lighting fixture. Consider using a thermal imaging camera to inspect the electrical panel and wiring connections. A thermal imaging camera can detect hot spots, which can indicate loose connections, overloaded circuits, or other electrical problems. When troubleshooting electrical problems, it is important to have a systematic approach. Start by gathering as much information as possible about the problem. Ask questions such as, when did the problem start? What were the circumstances surrounding the problem? What have you already tried to fix the problem? Once you have gathered enough information, develop a hypothesis about the cause of the problem. Then test your hypothesis by performing various troubleshooting steps. If your hypothesis is correct, you should be able to identify and fix the problem. If your hypothesis is incorrect, develop a new hypothesis and repeat the process. By following a systematic approach, you can increase your chances of finding and fixing electrical problems quickly and efficiently.